My name is Ilpo Mäkinen, and I have a pleasure to talk about Juniper AI networking today. I was planning to split the presentation in 3 parts. First of all, I wanted to talk a bit about what it means from our perspective to be AI native instead of AI bolted on afterwards as an afterthought to the network. The second part, I want to try to avoid as much as possible the different buzzwords and that kind of stuff, and give some concrete examples what we do in AI networking. And the third part is a bit about the peek to the future. What do we do next? Obviously, we've done this AI networking in Juniper Mist for more than 10 years now. And we didn't stop. We've been very successful, and the next steps are super exciting as well. So that's my topics today, and let's start by defining, I mean, why we are doing this, and what is the whole point in AI networking. And I do know that everyone is talking about AI this, AI that, machine learning this, machine learning that. I mean, it's overwhelming. Let's put it that way. So why do we do it? And for us, it all started from the need to actually understand how the user is feeling, what kind of network service the user is getting from the network. That was the #1 thing we wanted to sort of resolve 10 years ago. And the next part is what actually the AI is for the network. And I think the AI for networking is the next evolution of automation for the networks. So that's the sort of basics. And when we started defining what do we actually need in order to do this, I think we figured out that it's at least 3 things that are in the real core of the solution, if you even wish to do anything like this. And it all starts from the right kind of data. I think you've heard this many times before, and everyone is saying that the data is the new oil and etc. It really is. But when you do want to do something clever with that data, it's not about all kind of data that is relevant. You need to have the right kind of data. It's not about the amount of data. It's not about how much data you have. It's about having the right kind of data. And that is really key. I give one example here. I mean, it might sound boring, I'm sorry about that, but one of the things that makes Juniper networks so different to any other network currently out there is that we've built inside the network a mechanism that allows us to collect that right kind of data from every device connected to the network. And we do that without installing anything. I mean, it can be your laptops, it can be your mobile phones, it can be video cameras, it can be IoT sensors, whatever. Regardless of the device type, we constantly collect actually more than 150 parameters from every device all the time. And those obviously are the right kind of parameters we collect. The second thing is that what do you do with this data? And that is obviously the algorithm part. So what we've done is that we've developed these algorithms to really crunch this big data that we have from all the clients coming. We've done these algorithms for more than 10 years, and they are actually pretty clever today. That is really what makes the difference. But in order to do all this, you also need to have the right kind of secure infrastructure that really has all the horsepower to do it real time. And for that one, we've built a microservices-based cloud that really has all the power to analyze the massive amount of data that we collect all over the network in a real time. So what we actually do is that we collect these 150 parameters from every device constantly. Every 2 seconds, we push that information to our cloud and analyze it in real time. So these 3 things needs to be in place in order to do any relevant things when it comes to the automation, when it comes to the AI, and when it comes to anything that you try to make the networks better with. We actually started it with campus and branch networks. That's where actually, if you've heard a company named Mist, Juniper acquired a company called Mist 5 years ago, a bit more than 5 years ago. That's where it all started. It actually started from the wireless side of the business, or wireless side of the domain, networking domain, because I mean, many people think that wireless is like a black magic. It's super hard to understand, and it's something strange is going on there. And that's where we saw the biggest benefits, and that's why we started there. But today, Juniper does it through all the networking domains, not only on the campus and branch, but also in the data center and also in the WAN side as well. And I mean, if you want to look into different networking domains, please visit our stand. We can talk and we can organize easily a demonstration for you guys and really show the power of this kind of new future network. Okay, that was the AI native. So we want to call ourselves AI native because we have this capability to gather this information, to really analyze it in a real time. That was it. But why do we do it? It's actually pretty simple. It's like with always in automation. Why do you automate anything? You automate things in order to save money, in order to save time, in order to save labor, in order to save man hours whenever you do those stuff. And that is what we are delivering with this kind of network. One final thing about the AI native before moving to the concrete examples of what we do with this AI networking. And it's a bit of a recap. We think that there's 4 really key things that differentiates us from all the rest of the players in the market. And like I said, we wanted to start by understanding how the client experiences the network connection. The old world always monitored and understood how the network devices are feeling. What is their sort of processor capacity available, how much they are using memory, or what is the temperature inside a access point or a switch or something like that. But we wanted to go further and really understand how the client is doing in the network. For that one, the concept that we have done is that we have these service levels for all the important things we think that are really important in that client experience thing. I mean, there's multiple things. Here, for example, is 3 service levels. In wireless, there's much more of those, and there's wired service levels and SD-WAN service levels in our system. But for example, time to connect. I mean, we constantly track how long it takes if you in the morning open a laptop, how long it takes that you have a connection to network. Is it relevant? I think it is. It's something to constantly track. So for example, in our system, the standard settings for those, and you can, by the way, you can tailor those, but standard setting is that it needs to happen in 2 seconds. If you open a laptop, it needs to happen in 2 seconds that you are connected to the network. Otherwise, we raise a red flag and we start to investigate more in detail what's going on there. The second thing, the second box here is really the operations. And when I said that in my mind, the AI for networking is actually the next evolution of the automation for the networks. That's really, really key. So what we do is that as we constantly track and measure what's going on in the network, based on that information, when we see that there's some improvements that we could do, some of those things we actually automate. So our system automatically configures itself and checks how did that go? I mean, did the client, after this configuration change, experience a better connection? Did he experience better throughput or roaming behaviors or whatever? So we always give a reward for that action that we took. Was it a good one? Was it a bad one? And then by that we teach the network to do even better decisions in the future. But it doesn't stop there, because there are some things that we cannot automate today. We see some kind of problems or some kind of challenges in the network, but we really, our machine really doesn't understand how it should fix those yet. So for those situations, we give you or your service provider the tools to actually do that fixing, to do that troubleshooting, to do that, to make it better. So what we do there is that we have different kind of, we call it AI assistants. Our AI assistant is called Marvis. And that Marvis in a clear English text says that, hey, I found a problem, you might want to take a look into this one. And it even suggests what it thinks that you maybe should do in order to fix this problem. And not only that, when we see that something is going really bad in the network, what we do is we actually go back in time and take a picture of that moment. So what we do is we do dynamic packet captures automatically when our system figures out that something is maybe not right here. So we provide the tools for you to do the actual troubleshooting. You have everything waiting in the cloud so that you can quickly resolve those problems that are happening. And the third box here, in order to be AI native, like I said, we needed to have the horsepower in the cloud in order to do all this instantly when we collect the information from the clients. But not only that, we need to be able to adapt to the changing world. And that's why we built our cloud using a microservices architecture. And why that is important? It's important because this allows us to take care of the backbone of the network. So it allows us to do the updates and upgrades to the network on your behalf. And that's part of the Juniper value that we provide whenever we sell the networks to you. So basically, actually, what we do is most of the year, every 2 or every 3 weeks, we actually update the system for you guys so that it has all the latest security patches, all the bug fixes coming automatically without any interruption to the network connectivity to any of your users. That's also difference that is super important. The fourth box here is something that we also wanted to add to the network. So we wanted to give more value from the same infrastructure that provides the connectivity. For this one, the example I have here is about location tracking, and that's done actually using a patented BLE technology that is already inside in the access point. So if you ever need later on to add a capability to really track where the users are, where are, for example, some hospital devices or some tools or whatever, you can enable this functionality in our system, and suddenly you get from the same infrastructure some added services on top of the connectivity that was probably the reason to build the network in the first place. And all this we do 100% API driven. And why this is important? It's important that we can do the integrations to the other systems. The networking is not an island. It's the fundamentals that provide all the clever tools and applications for your use. We not only want to track and see how those applications are working for your users, but we also want to integrate to those ones. Let's take an example. I mean, Teams and Zoom, I think everyone is nowadays using those. With Teams integration, for example, what we do is we actually integrate, we bind our cloud to your Microsoft cloud. And with that one, we not only understand what's going on in the network, but we also understand what's going on in the client device that you're using. Then we get that information that, yeah, during the Teams call, I mean, your memory usage was like this, and your processor CPU capacity was like this, and blah, 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 all that kind of stuff, and also from the cloud side. And then we gather all this information in a single view for you to understand how those calls were felt by your users. And in case of any troubleshooting, you can actually ask in our system in clear English that troubleshoot application Teams for Ilpo during the last 7 days, for example. And the system gathers all the information, shows all the Teams calls that I did, and shows how those calls went. How was the network during the calls, and how was the Microsoft Cloud seeing the call quality during the call. Everything in a single view. Okay, this was the first part. That was the AI native thing. Let's talk a bit about then what are the concrete use cases that we use the AI for. And this is something that I could talk hours and hours. I chose 2 concrete examples just to sort of show a bit about how we do things differently. Usually, if you think about the AI sort of methodologies and things that you do, it's easy to split into 2 things. It's easy to split to the machine learning part and then the deep learning part, which is at least I think the most sort of interesting one. The machine learning tools and the methodologies has been there for 30, 40, 50 years already. But what is developing super fast is the deep learning things. And this is important because, I mean, these AI-driven networks, the really key value of those is that they constantly get better. And that's where we want to aim our operations as well. We want that it's good from the start for you, but as you use it more and more and more and more, it would actually learn your use cases, it would learn your environment and make it even better. So let's take one example of that one. And this is a classic, it's not a classic when it comes to networking. I think we are most likely the only ones doing it this way. But this is an example of reinforced learning, if you're familiar with that sort of AI methodology. So as I said, we constantly track and understand many things about how the clients are doing in the network. Like I said, I told about this example of time to connect. I mean, we track, does it take more than 2 seconds to get connected when you open the laptop, etc. But we track all these things to understand what could be even better. And when we see an opportunity that it could be even better, with this RRM, AI-driven RRM is radio resource management. So it's a term that has been used within the networks for years and years. It's about choosing on which channel to operate, what kind of transmit powers you are using, etc., etc. But the difference with Juniper to all the other vendors is that as we understand how the client felt, we then automate and we change the configurations constantly to make the client feel even better. And we always, after the change, we measure how did it go? And by understanding how that change affected to the user, then we feed the reward. So we reward the system and automatically teach the system to always be better. This sounds like some fairy tale in a way, but I give one example from live customer here in our region is that actually they had huge challenges with the wireless network. They bought a new wireless network they wanted to get rid of the challenges. Nothing happened. Same challenges went on and on. They bought another network from another of our competitors. They thought that this must be the one. They market it's an AI network, so it must be better. Nothing changed. All the problems were still around there. So then we went to see the customer. We obviously were way too late. We should have been there in the first place already, but finally, I mean, better late than never. So we went there and they said to us, hey, no, Juniper, sorry guys, we've already purchased 2 networks. We are not going to purchase third one. I mean, they also marketed that it's going to make the difference. So we insisted that, hey, give us a pilot. We will loan you the stuff. Please experience it yourself, what the AI can do. So they agreed on that one. We loaned them Juniper campus network, so it was Juniper switches and Juniper access points. And in less than a week, all those problems disappeared. Later on, we tried actually to understand what was going on. And parts of it we did figure out. So we did figure out that the problems were caused because of the ferry coming to the harbor and all those radar systems leaking to the frequencies that we operate on. And the standards are written in such a way that if there's any energy in those channels, all the wireless networks needs to be quiet. So that's what happened in these competitor networks. In the old world, RRMs, those guys then try to, they guess another channel, they guess another transmit powers, they guess something else, and they just try, does it work? It didn't. But with this one, we understood from the client side, and we also, actually one of the sort of technical things in our access points, we always have an extra radio in our access points. Its only purpose being to constantly scan all the frequencies and all the channels and gather more food to our AI algorithms. So, but because of those basically 2 or 3 things, we figured out that there's something going on every Tuesday and Thursday when the ferry arrives, and on those dates we found a channel settings that didn't collapse with those ones, and everything just worked. Sounds super simple. It sounds almost too simple, so we wanted to understand more. So we wanted to understand why did our system do these changes. But actually, we couldn't find out. Because the system constantly teaches itself, we not always understand why they do these changes. They just work. And that is the power of these new kind of AI methodologies. But in order to do it, obviously it all starts by being AI native, so having the right kind of telemetry information. That's the first thing. And then you need to have these developed algorithms that we've developed now for more than 10 years, like I said. I wanted to take another example because the radio resource management, some of you might have heard from me or my colleagues already talking before, but I wanted to take another example from not actually from the sort of user, well, obviously it affects the user experience as well, but this is how we eat our own dog food thing. So we not only measure how the users feel in the network, but we also do that for all of the devices that we put into the network. And funny enough, but radios and access points are kind of animals. It's not a vendor-specific thing, but I mean, over time, there becomes different kind of problems. So obviously, we want to use these AI methodologies for that as well. So we constantly track what kind of things are going on in the radios. We track. I mean, we compare how these access points, beacons, how many there was those, and how did it go with this another access points. What in general in these premises, etc. So based on those, we actually can predict when the radio is going bad. And what is how do we sort of resolve that kind of issues? Sounds again stupidly simple, but we reboot the radios. So that's what we try next. So we reboot and we then track again, I mean, how did it go? But the nice thing for you, our customers, is that when we figure out that even this rebooting or our other sort of operations that we did for the access point didn't help, we actually contact you that, hey, we'd like to change the access point. Please give us the shipping address. Where do you want us to ship the access points to? So it's a proactive thing. I mean, instead of waiting something going bad and you guys contacting us, we do that on your behalf before, hopefully, you experience any problems. The AI is such a broad thing, and everyone is talking about AI, and there's this. Some people talk about, and it's a sort of, I think it's a common way to describe that there's a narrow AI specific for some specific things. Then there's the sort of general AI, and then there's the Skynet AI, and all those kind of AIs. But what we do are really, really concrete things just to make the network operate better. I mean, let's put all the buzzwords aside. There is the methodologies and the algorithms are something that is really, really key, and it is true, and it's reality. And we utilize that to make the user experience better and to make your experience as a network owner better. I have a bit more than 10 minutes, so the final part of my presentation was about the future of AI for networking. What do we do next? What I so far explained was all kind of dependent on understanding the user experience. That's all the basis. So we need to collect that data from the users. And based on that, this green guy, this our AI assistant, Marvis, spots those problems, tries to fix those problems, and if it's not able to fix those, then it raises a red flag and tells you how it thinks those might be resolved. But what about the situation that all these workers in your office go home at the afternoon or evening? What if something happens in the network then? And this is the next part of the AI for networking. So what we want to take, the next step we want to take is to try to utilize these AI methodologies without having users actually in the network. So for that, we send these little green guys. We call them Marvis Minis. We sell these minis to all the networking devices in your network. We send those to access points and switches and all over the network. And what these guys do is they automatically figure out how your network operates. They automatically understand your network settings because they see what kind of traffic there is going on. And based on that understanding, they create these digital experience twins. So they are the digital twins of users. And what they do when all your workers are home sleeping or away from the office during the weekend, these guys start testing. because there's no users generating this telemetry information. These guys start generating the telemetry information. So they test against different network settings, network applications. They can test, I mean, if you have some important application for your business, you can just add that to the list of tested items. So during the night, these guys do all that kind of testing, and obviously the reason for doing this is try to avoid the problems. So when the workers come back to the office in the morning, we would already understand if your applications are working, if your network elements are working, if your settings are correct. They do it all without any configuration. They just automatically, if you buy the subscription from us, the Marvis subscription from us, they automatically start doing those. But you can also manually trigger those. And it's a good idea to do those whenever you do any other changes to network, whenever you do some changes to your setup, regardless what it is, then just manually trigger the Marvis minis to do the testings, and you see if something went wrong with those configuration changes that you did to the network. So these are the only, and again, I mean, like I said, we've developed these algorithms for 10 years, and we've been very successful. I mean, we're winning a lot in the market, but we didn't want to stop there. We wanted to think about the next step, and this user experience twin is really the next step. It is providing the learning opportunity for the network even without users in the network. That's the point. And just imagine all the possibilities. We are now at the first stage of this. So these are now already live. They are testing DHCP services. They are testing your applications that you set up in the system. You tell the address of the application that is important for you. So that's already now going on, but it will not stop there. You will hear more about this in the future. And all the great stuff that we did from understanding the user traffic, we do also with these ones. I mean, if these minis, if these digital twins that are living in the network devices, they are living in the access points and switches, etc. If those figure out the problem, they also do a dynamic packet capture. They also take a picture of that moment. They also save it to the cloud so that when you come to the work, you have it all there and can start really resolving the problems. I tried to avoid the marketing slides, but I have 3 of those. I'm sorry. I would get my manager would get mad if I didn't show this. So I think many of you have seen these Gartner leaders quadrants for many times. This is the quadrant for wired and wireless. In that one, we've been now 4 years in a row as a leader, actually 3 years as a leader of the leaders. If you wish to read this, I think it's a good one. Just scan the QR code and you can download it from us and see it, or come to us and we can provide it to you later. Why these are here in my slide set, I just wanted to sort of also show a bit of a proof of how this AI is real. I mean, we obviously see it from several things. We win in the market. We have all kind of we are winning in all kind of customer segments, regardless if they are healthcare or government or retail or manufacturing or whatever. We are also winning in all sizes of customers. This solution is so nice that you can get the benefits even if your network is only one access point. You can already then make the network better. Our largest customer today utilizes 390,000 access points in their network, so it scales, I would say, unlimited. I mean, there's no limits really to the scale. And the nice part, using a microservices-based cloud is that you don't need to do any upfront investments. You only buy those access points and switches that you need, and you're good to go. I have here another leaders quadrant, which is actually showing about that indoor location capabilities. I mentioned that we have the capability to track and locate devices very accurately. Actually, the accuracy is in approximately 1 meter. We can show that approximately within 1 meter's area this client is located. We do that, by the way, in real time as well, which is a difference as well. Why I had it here is that actually in this report, we are the only networking vendor in the leaders quadrant. All the other vendors are kind of these tag vendors or some specific systems. So our value is that when you anyway set up the network infrastructure, you can get more out of it just by enabling it whenever you wish so. And the final report, we are happy to provide this to you as well. Please ask from us if it's interesting. It goes a bit small in text, but this is actually quite good when you're considering a network refresh or network upgrade. Gartner also has this kind of report of critical capabilities. And they've listed these 5 capabilities that are critical when you do the refresh. We are leading actually in all of those. In one of them, we are on a shared #1 position. All the others, we are #1. I want to end this presentation with just stating it one more again that AI, I mean, obviously, I mean, you hear AI every day, everywhere. It's sometimes actually quite hard to understand what is meant by AI. What we mean by AI is next generation of the automation. What we mean about this is better user experience and better operator or customer experience in general. And it is real. The benefits are real. I mean, I'm sorry, these examples always, because this I know that this is streamed, I have to use my sort of official slides. I couldn't put up local customer names here, but the local customers are getting exactly the same benefits as these US customers. For example, I mean, I have 2 minutes, so for example, I mean, we have a Gap here. Gap is a retailer. They have 3,700 clothing stores in US. Since moving from a competitor network to Juniper Mist network, they actually said that their need to send technician on site was reduced by 85%. They made a calculation that the return of investment for the Juniper network was actually paid back in less than 1 year because of these kind of things. Another example, ServiceNow. Everyone knows ServiceNow. And funny enough, I mean, it's amongst other things, it's also a ticketing system. When they went to Juniper Networks, their internal ticket number was reduced by more than 90%. Again, it sounds like it's some fairy tales or some dreams here, but it's actual, it is real. This is the power of AI. This is the power of AI native networking. And with that, I want to thank you for the interest. If there's any questions, I'm happy to pick those. Was there anything coming? Thank you.
Thank you. Yes, there are some couple of questions. It seems that OpenAI API is behind everything, 90% of solutions. So does Juniper use something from that, or is it everything in-house built?
No, everything is not in-house built, and we do use large language models as well. So we utilize this Marvis that I was mentioning, that AI assistant that we have. You can interface with that one in several ways. It gives you nice graphs, and you can click and always go deeper and deeper into detail. It also gives you a kind of a task list that whenever Marvis figures out something, it gives you a task list that when you come at work in the morning, you can check what it suggests you to do. But also the third one is actually, you can actually type it, and for that we use GPT and large language models. The only difference is that we didn't teach it with all of the internet data and with all of the Shakespeare novels. We actually teached it with 10 plus years of our understanding on the networks, and we teached it with all of the Juniper manuals, all the configuration things. So it knows only about networks. It can tell a couple of jokes. If you tell a joke, it gives some very bad jokes, but other than that, it's only networking.
Okay. And if AI finds the problem and then reports it via Marvis, do you have any mechanism also that user is fixing that setting, or it is just constantly reporting and there is problem and then
No.
What happens?
So we definitely do have a mechanism, and you can track that as well from the Mist dashboard. So it actually tells you when AI has found a resolution to that problem. So it logs you that, hey, we found a problem and we fixed it. So it fixes some kind of problems. But by the way, with problems, it's super important that we don't sort of overburden with problems. So we want only to show you the ones that we really know that there is something that needs to be done. I mean, no one today wants to look hundreds of thousands of logs showing some red colors there, and it's really fine-tuned in that way as well. So it both fixes and then it gives suggestions for humans to fix.
Okay. And we have a question in Elisa's stage that about security. How does Juniper keep the data secure that is passed from devices to the cloud?
That is a very good question. And first things first. So never any payload, actual data, is transmitted to our cloud. So what we do is we take headers of all the packets, and that's what we send to the cloud. In addition, with this 150 plus states of every user device. So we never send any actual payload to cloud. That's the first thing. And then obviously all the modern security mechanisms are in place in the cloud that we utilize. But first things first, user payload never goes to our cloud. It always stays local.
Okay, thank you. And we are end of questions. So
thank you.